Hi guys, this video is about naming and writing formulas for binary ionic compounds using the crisscross method. Crisscross method is a method that we're going to relate to the charges the atoms have individually and cross them over. Okay, so charges will become ratios, essentially. So we'll talk about that in a minute. Okay, so what are binary compounds? Well, binary compounds are compounds composed of two elements. So for example, you have KF, MgCl2, AlCl3. So here you have a 1-to-1, a 1-to-2, a 1-to-3 ratio. Okay, that's important. Binary ionic compounds, they form that ratio. It's a very special part to these compounds. These ratios tell us how many of the atoms we need to make a neutral compound. So for example, aluminum has a +3. You need one aluminum to react with 3 Cls because each Cl has a 1-. So 3 single negative charges neutralizes the 1 + 3. Magnesium has a 2+, so you need 1 magnesium to 2 chlorines. And here potassium has a +1, fluorine has a -1. So then there, you just need one of each. So the ratios help figure out and neutralize the actual atoms in the compounds. Now there's 3 steps for writing formulas for binary ionic compounds that we're going to start with. Okay. So let's look at example 1. So here we're giving a name. We want to write the formula. So 3 simple steps. What you want to do is just find their essential symbols. Okay. So step 1 is write the symbols for the ions side by side, and the cation always goes first. So for example, in the periodic table, calcium is Ca, it's found in group 2a, so it obtains a 2+ charge. Bromine is Br, it's found in group 7a, has a 1-. All right. Step 2 is cross over the charges using the absolute value of the charges. So in this case, we want to take the number here, 2, and crisscross it over. And this one here, crisscross it over to there. So let's see. So we cross over just the numbers, not the actual charges. They stay out of it. Okay, so in this case, it's going to become CaBr2. It's a 1-to-2 ratio. 1-to-2. Oops. Okay, that's our ratio. Okay, 1 calcium for every 2 bromines. Okay, calcium's got a 2, bromine's got a 1-. So you need 2 bromines to neutralize the 1 calcium. Okay, very simple. So let's take a look at step 3. Okay, now in this case, check the subscripts and divide them by their largest common factor to give the smallest possible whole number ratio of ions. Now, in this case, CaBr2, the largest common factor is 1, so you can't actually reduce it. So the final formula is just CaBr2. Okay, but what if we have something a little different? What if we have X2Y4, the 2-to-4 ratio? That's really XY2. Reduce it when you can. So let's say if we had X6Y3, that's going to become X2Y1. Okay, very simple. So you reduce when necessary. So these are the little mathematical skills to figure out which is the right number to divide each one by, and you reduce it. Okay, now let's look at this next example, magnesium sulfide. Okay, first step is write out what the symbols are. Okay, magnesium M, sulfur is S. Magnesium has a 2+ charge, right? Sulfur has a 2-. Great. Now what you want to do is, now that you have the charges, set up the step 1. You want to cross over the charge number, like so. 2 goes there, and the 2 goes there. So it becomes Mg2S2. Okay, then you want to reduce. So in this case, you want to reduce this, and you could divide each one by 2. Okay, so it's going to actually equal M G, S. And that's it. Simple as that. Just cross over the charges and reduce when necessary. Trying to keep this simple. Okay, let's look at the next one. Iron III oxide. Iron 3. Okay, remember that Roman numeral. That Roman numeral here goes with the iron. Because remember, iron has two possible charges, +2 or +3. Okay? Oxygen only has the one charge in group 6A, has 2-, but iron is iron 3. So we're going to write the 3 there. Not 2, it's iron 3 because the Roman numeral written right in the formula. Don't forget about this, it's very important. So the 3 goes over to oxygen and the 2 goes over to iron. So it becomes Fe2O3. Okay? Can you reduce that? No, you leave it as is. Okay, very simple. So you need 2 irons and 3 oxygens to make this reaction happen. Okay, so you have 2 negative, so 3 of them, 6-, okay, 6 negatives for the oxygen, and 2 times 3, 6 positives for the iron. Okay, so it neutralizes. That's why we do this crisscross method. Okay, Chromium VI Nitride. Okay, so chromium is Cr, Vi is 6 plus, nitrogen is N3 minus. Perfect. Okay. Now we crisscross. The 6 goes there, and the 3 goes there. Okay, crisscross. So it becomes Cr3N6. Okay. Now we reduce. Divide each one by 3, because that's what we're looking for. Okay, so it becomes Cr(N). 6 divided by 3 is 2. Okay, so the ratio is 1 to 2 on this one here. Be very careful with reducing. Okay. Next example, copper II Phosphide. Okay. Copper 2 plus, phosphide is P3 minus. Okay, phosphorus is in group 5A, so it gets a 3- charge. That's a 3. Okay, then we crisscross. 2 goes over there, 3 goes over there, so it's simply Cu3P, that's a P2. Okay, Cu3P2. Okay, done. Okay, that's not too bad, right? Okay, now let's look at naming binary ionic compounds. So in this case, let's start out with the formula. Okay, so the formula is given, then you have to write the name. Okay, so in this case, let's just say we have MgCl2. Okay, now in this case, both elements only have one charge. Now there's a couple steps we have to be familiar with these because we have to watch out for transition metals. Okay, both elements have only one charge. Name it as you see it. Okay, so magnesium just has one charge. So this one here is just simply magnesium chloride. Magnesium chloride. Now this one here, SrN2.